All right, Math 2, here we go. We got a lesson 8.2.1, angles of polygons. All right, so the sum of the interior angles of polygons. So the interior angles are just like these three angles here. And we've done something like this before. We had something called the triangle angle sum theorem. And we said that a triangle has 180 degrees in it. So if you add up all of these three angles here, you should get 180 degrees. Now here I've got a rectangle, and we know that the rectangle has four 90-degree angles. So in a rectangle, we know that we got 90, 90, 90, that's 270, plus 90 more. That ends up being 360 degrees. All right, so those are the ones that we should know. What about ones that we don't know? Like a pentagon here. We got 5 sides. How could we find out how many degrees that we've got inside of there? Well, one thing that we could have done over here, in the last section, we looked at splitting up quadrilaterals into triangles. That, we could use triangles to find out stuff about quadrilaterals. So if I make a point here that goes and makes 4 different triangles there. Inside, these aren't the interior angles. These are just some angles that we made up. But we would know that these 4 angles here would have to add up to 360 degrees. So these 4 angles there make up 360 degrees. Now this triangle here, the whole triangle is 180 degrees. This triangle here is 180 degrees if we have all 3 angles added together. You remember we said triangle sum over here. This triangle over here is 180 degrees. This triangle over here is 180 degrees. So I've got 180 in this triangle, 180 in this triangle, this 180 in this triangle, 180 in this triangle. So that's a total of, let's see, 360 plus 360 more, that's 720. So we got a total of 720 degrees. But then we said that these angles in here were not part of the interior angles. So if I take out these 360 degrees there, what are we left with? 360 degrees. I put the degree on the wrong side. Why did I do that? I don't know. So like I said, we made this into 4 triangles. Each triangle has 180 degrees in it. Now these angles are part of the big shape, but the angles right here aren't part of the interior angles. Those are just angles that we made up. So we just do 720 minus 360, and we find out that that should have 360 degrees. So the same thing can be done with this shape here. We can make a bunch of triangles. We would know that these 5 angles, since they go all the way around, that's a 360, right? So that's 360 degrees. So now this triangle is 180, this triangle is 180, this triangle is 180, so is this one, and so is this one. So how many triangles do I have there? How many 180s do I have? I got 5 180s. So 5 times 180 should end up being, 900. If I do 900 minus 360, I should get 540. So that's how many degrees we should have for the sum of the interior angles. Can we identify a pattern? Okay, so here I had three sides, and that gave me 180 degrees. Here I had 4 sides, and that gave me 360 degrees. And now I have 5 sides, and that's giving me 540 degrees. So what's the pattern? Each time I add a side, what's happening with each of the sum of the interior angles? Well, it looks like I'm adding 180, I'm adding 180. It looks like each time I add a side, I add 180 degrees to the sum of the interior angles. So we add 180 degrees for every side added. So finishing off this chart here, we've got 4 sides was 360, 5 sides we said is 540. So now if I add 180 degrees to 540, we should get 720. If I add 180 degrees more, I should get 900. If I add 180 degrees more, I should get 1080. When I jump from 1080 to 100 sides, that's a little bit harder. So what we should do instead is come up with some kind of equation here. So if we look at it, it looks like here when I have 3 sides, I have 180 degrees. Okay, so I'm definitely going to have 180 degrees with 3 sides, but I'm only going to have how many? I'm only going to have one 180 degrees. On 4 sides, I have 2 180 degrees because 180 and 180 is 360. 5 sides, I have 3 180 degrees. 6 sides, there's 4. 7 sides, there's 5. There's 5 180 degrees right there. And here we have 6 180 degrees. So it looks like it's always the number of 180 degrees that I have here is always 2 less than the number of sides. See, when I have 3 sides, I have 1 180 degrees. When I have 4 sides, I have 2 180 degrees because 180 times 2 is 360. So it looks like we can say that the sum of the interior angles should be equal to 180 times the number of sides minus 2. Because when I have 3 sides, plug 3 in right here. 3 minus 2 is 1. I have 180 degrees. When I have 4 sides, plug in 4 here. 4 minus 2 is 2. I've got 2 times 180, 360. When I plug in 5, I plug in 5 here. 5 minus 2 is 3. 3 times 180, there's 540. Okay, now that we know that, we can come up with our 100 sides. So basically what we would do for 100 sides is we do 180 times 100 minus 2. So that's 180 times 98. So 180 times 98 ends up being 17,640. So for the n number of sides, we always just do 180 times n minus 2. And that tells us what's the sum of the interior angles. Moving on. Find the value of x for the regular pentagon. Okay, so regular means that all the angles are the same and all the sides are the same. So all these angles are the same. Let's count up all of our sides here. I've got 1, 2, 3, 4, 5, 6. I've got 6 sides. So using the formula that we've developed here, I can find out, well, we already have it actually right here, 720. So if I plug in a 6 here, up here on my chart it says I should get 720. So 720 total degrees. All of these x's should add up to 720. Since there's 6 of them, we would just divide by 6. And 720 divided by 6 ends up being 120. So each x should be 120. Okay, next shape. Okay, so this one we're going to assume is a regular shape where all the angles are the same and all the sides are the same. There are 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides. So in an 8-sided object, we have 180 or 1080. So there's a total of 1,080 degrees and all of these angles added up. Since they're all the same, I would divide by the number of those angles. There's 8 different angles there. And so 1080 divided by 8 gives me 135 degrees. So each of those should be 135. Let's come up with a formula for this. So if n is the number of sides, I know that the total number of interior angles is always 180 times n minus 2. So if I wanted to find each individual angle, I would just divide by the number of sides, which is n. So there's our formula for finding the single interior angle when it's regular. So this only works when it's regular, because when it's regular, all of the angles are exactly the same. So if I want to find the single angle of a regular nonagon, nonagon means that it has 9 sides. What I would do is I would do 180 times n minus 2, 9 minus 2. So that tells me the total number of interior angles, the sum of all the interior angles, and then I would divide by 9 because they're all the same. So if I do 180 times 7, because we're going to do 9 minus 2 there, I get 1260. And then 1260 divided by 9 comes out to 140. So on a nonagon, a 9-sided shape, we should have 140 degrees for each of those. All right, let's flip it over. All right, let's talk about exterior angles. Exterior angles are when we've got a side and it just keeps on going, and that's the angle on the outside of the shape. So the exterior angle would be over here on the outside of the shape. Now I've got 1, 2, 3, 4, 5, 6 sides. And we said earlier when we have a 6-sided shape that they add up to a total of 720 degrees. And on 23A, this problem right here, I found out that each of these angles was 120. All right, so the interior angle is 120. Well, the interior angle and the exterior angle have to add up to 180. They have to be supplementary to each other. So if this is 120 and this makes a straight line, this is going to be 60 because a straight line has 180 degrees in it. So the value of the exterior angle A over there is 60 degrees. All right, what's the sum of those exterior angles? Well, all of these are 60. 60, 60, 60, 60, and 60. So all of those are 60. So now I just have to do 1, 2, 3, 4, 5, 6. There's 6 exterior angles. So I do 60 times 6. And the sum of the exterior angles ends up being 360 degrees. All right. Now we're going to find the sum of the exterior angles for different shapes. A quadrilateral, that's 4 sides. So here's my quadrilateral. I'll just do a square. The exterior angles would be when we keep on extending out our sides. So these would be my exterior angles, these angles out here. Well, the interior angle we know are 90, because I said I made a square here. So if the interior angle is 90, remember these are supplementary, the exterior angle has to be 90. So if the interior angle and the exterior are 90, we can add up those exterior angles. There's 4 90s. 4 times 90 is 360. All right, octagon. Let's go back to the last page because we just did an octagon there. Okay, we're doing an octagon here. We said that the interior angle was 135. So let's make an exterior angle. So these are all the different exterior angles. All right, so if this is 135, remember they have to add up to 180. It looks like this would have to be 45. And there are 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon, so there's 8 of them. So 8 times 45. Well, 8 times 45 is 360. Do you notice something here? Exterior angles, the sum of the exterior angles for the hexagon, 6-sided object, was 360. Quadrilateral, 4-sided object, the exterior angles added up to 360. Octagon, the exterior angles added up to 360. I'm starting to notice a pattern. It looks like every single time that the exterior angles add up to 360, no matter what. So for a dodecagon, a 12gon, we should still get 360. Don't believe me? Let's prove it. Let's just look at one of the angles. Let's pretend that this dodecagon is regular. So remember, to find out the interior angles, we do 180 times 12 minus 2. So this is the sum of the interior angles. And then we would divide by the number of sides, which is 12. So this is 10. So this gives me 1800 divided by 12. So the total interior angles of this dodecagon would be 1800. And 1800 divided by 12 is 150. So this is 150. That's the interior angle. So this exterior angle would have to be 30. Right? Because they always have to add up to 180 degrees right there. Well, what's 30 times 12? Yep, 360. So no matter what, the exterior angles always add up to 360. So what's the formula to finding the exterior angle of a regular polygon? The exterior angle sum interior. So the sum of the exterior angles, no matter how many sides we get, it's going to be 360. So the interior angles change, but the exterior angles don't change. And this is actually really helpful because you can do this formula, 180 times n minus 2 over n, or you can actually make it easier on yourself. What if you had a, oh, let me move so that the lights don't turn off on us. All right, so I moved around, so hopefully the lights won't turn off. Let's say that we had a, let's say a decagon. So a decagon, that's a 10-sided object or a 10-gon. Let's say that we wanted a regular decagon and we wanted to find out what each individual interior angle would be. Instead of working with the interior angles, what I could do is work from the exterior angles. So each exterior would just be 360, because the exterior angles always add up to 360, divided by 10. The exterior angles would all be 36 degrees. And then what's the relationship between exterior and interior? The interior angles have to be supplementary to the exterior angles. So each interior would end up being 180 minus 36, or 144. A lot less work. We could have gotten the same answer another way. We could have done 180 times 10 minus 2 divided by 10. So we could do that if we want to. So this is the old formula. We can do 180 times 8 divided by 10. 180 times 8 ends up being 1440. Divided by 10 is 144. The same answer I just got right here. So if we work from the exterior, there's a lot less work that we have to do. But we can use that formula that we developed on the other side. That's all I got for you. Math hard. See you later. Bye-bye.